Alright, so we're looking at question 9 from the 2013 exam. So by introducing slack variables and artificial variables as appropriate, and using the Big M method, we aim to write down the first tableau of the simplex algorithm for the following LP problem here, and we get to write our answers in the tableau down here. And lastly, we'll circle the entries that we would pivot on once our tableau was completed. And to make sure we don't forget that, we're going to highlight this, like so. Okay, so the first thing we do now is to rewrite the constraints that are given to us. And how we do that is we replace greater than or equal to signs or less than or equal to signs by equal signs. And the way we do that is by introducing slack variables and artificial variables. Now in this question, we have a greater than or equal to sign here and the number 0 following it. And it turns out if we have a less than or equal to sign here rather than greater than or equal to, we only have to use one slack variable rather than one slack variable and an artificial variable to make this an equal sign. So what we'll do is we'll multiply this constraint, both sides of it, by -1. So that gives us 4x minus y is less than or equal to 0. And that'll make things slightly easier, and it'll mean that we'll introduce one less variable for this LP problem. Alright, so now let's get these greater than or equal to signs and less than or equal to signs into an equal sign for each constraint. So firstly we'll start off with our top constraint, or our first constraint, and we'll rewrite that. So we've got 4x plus 5y, and because we do have a greater than or equal to sign here, we'll need to introduce both a slack variable and an artificial variable. So to do that, we introduce s1, which is our slack variable, but notice that it'll have a coefficient of -1 in front of it, and then we'll add our artificial variable in there as well. And we do that and add the artificial variable to make sure that our table is in canonical form. Alright, now let's do our second constraint. So we have -2x plus 3y, and then we give ourselves our second slack variable, s2, and then add our artificial variable, similar to what we did above here for our first constraint, and then that equals 3. Okay, so now finally, for our third constraint, we have a less than or equal to sign here. So we only need to add a slack variable to this constraint to give ourselves an equal sign. So let's do that. So we have 4x minus y plus s3 equals 0. Okay, now we move on to the next part of the problem, which is rewriting our objective function up here using the Big M method. Okay, so we aim to drive out the artificial variables, in this case r1 and r2, and we do that by making it an unfavourable part of z by introducing a new objective function. So let's do that now. So we still have the first part of z remaining the same, but now we make the artificial variables r1 and r2 unfavourable by multiplying it by -m, where m is large and positive. So hence this is now the unfavourable part of z as we aim to maximise z. Okay, so now to rewrite this by substituting in r1 and r2, by making r1 and r2 the subject of the constraints 1 and 2 respectively, and that'll equal to 2x plus 4y plus m multiplied by 2x plus 8y minus s1 minus s2 and minus 7. Alright, so now let's move on to filling in our tableau. Okay, so here are our variables up here and z down here. Notice I've given myself a bit more room for x and y, and that'll become clear a bit later on as to why I've done that. Okay, so let's start filling in our tableau. So for the first row, I'll be using the first constraint, which is standard for all of these problems. So our coefficient in front of x for the first row is 4, in front of y is 5, S1 has -1 in front of it, and R1 has 1, and S2, S3, and R2 don't make an appearance in here. And then finally we have 4 in our last column. Okay, now for the second constraint, I'll do that a little bit quicker. So for x we have -2, y we have 3, have 0 for S1, -1 for S2, 0 for S3, 0 for R1, and then 1 for R2, and then 3 in the final column. And for our third row, we use the third constraint, which is 4, -1, 0, 0, 1, 0, 0, 0. Okay, so at this point we can quickly write in what our basic variables are here. So for the top row, we have that R1 is a basic variable. For the second row, we have R2. And for the third row, we have S3. Okay, so finally we're ready to fill in our Z row. And we do that as normal, but also notice that we have this M part here of the objective function too. Okay, so let's look at this X column here and this entry here. Okay, so we have -2 for this part, but also notice we have 2mx for this part too, so we have to minus 2m as well. Okay, and now for y, we have -4, and then -8m as well for the m part. And now it's a bit clearer as to why I gave myself so much room for x and y. Okay, so now we move on to S1. Now because we have -m S1, that just gives us m down the bottom, and same for S2. Now 0 for S3, R1 and R2, and then finally we've got -7m up there for the constant. Okay, so now we've finished our tableau. But finally, we have to go back up the top. We circle the entry that we would pivot on, given this initial tableau. So initially we have to look down at the Z row and find the most negative number, and we find that by looking at the M parts of each of these ones down here. And because -8m is less than -2m, this will be the column that we'll be looking at to pivot on. So in other words, y will be our entering variable. Okay, so now we have to look at the ratios 4 on 5, 3 on 3, and 0 on -1, and we're after the least non-negative ratio out of these three, and in this case it's 4 on 5. So our pivot element is this element here, and that's it for this question.